Hello friends, I welcome you all on India's largest and number one e-learning educational platform, that is Gradeup. Friends, today we are going to have one more important topic to be discussed for your subject power system, and this session belongs to the post-GATE guidance series that we have just started after the GATE 2021 examination. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear so that we can proceed. And before you report me this, let me just brief you what is going to be the outcome of this session. This is very, very important, because then only you will be able to understand that if you follow this session completely, then what you are going to get at the end of this session. Friends, today we are going to discuss one of the two most important, significant and very frequently asked concepts in power system, that is skin effect and proximity effect. So everybody just tell me in the comment section, are you able to follow me in that so that we can proceed? Let me just quickly go through the session, but before we start, everybody please follow the LSS method. If you think that you are getting something good, something additional, good value addition you are getting, then please like the session. And if you think that there is something extraordinary you are getting from the session, do not forget to share it with your friends and colleagues so that more and more people can be benefited. And do not forget to subscribe the Gradeup Gate YouTube channel so that you do not miss any of the important sessions from your favorite faculties. Hi Kumar Sena, Medha, good evening, welcome to the session beta. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, 10 plus years of teaching experience, completed MTech from IIT BHU in 2010. I have written a couple of books also on engineering ethics and power system. Engineering ethics 2019 edition book, you will find my name. Power system book is yet to be released, and maybe this year, July, it is going to be published. These are my areas of expertise which I deal with my students, that is power system, electrical machines, electromagnetic field theory, material science and engineering ethics. Before we start the session, a very important information regarding the Vision 2022 course, which is one of the most exhaustive course for all the aspirants who want to prepare for engineering services, GATE, ISRO, BARC, any other PSU. Because this course gives you both technical and non-technical expertise required for most of your examination. What you are getting in this course is 850 plus hours of live classes, 8000 plus quality practice questions, 100 plus mock test, 120 plus chapter wise study notes. For any further clarification, you can contact this number. I hope you will be assisted positively. I hope that number is not visible, so let me just write the number here. It is 96500-52904. This is the Gradeup helpline number. If you want any information, you can contact this number. I hope you will be assisted positively. Everybody just tell me in the comment section, are you able to follow me in that? Friends, Gradeup is also offering you February Mela offer, which we started in the month of February, and only 3 days are left, but the number of days are not going to be important because these coupons are going to be limited in numbers. So everybody who wants to avail this offer, that is flat 50% off on the Gradeup Super subscription, go for it as early as possible. My friend, now the Gradeup Super subscription has been restructured to meet the requirements of various students. Instead of having the time validity orientation, now this subscription has the exam oriented validity. For example, you have to choose which examination you want to prepare, and respectively you will be getting the validity. So there are 3 different categories. Whatever exam you want to prepare, you can go for it. And if you join the Gradeup Super subscription in the month of February as soon as possible, because these coupons are limited, you will be getting some additional benefit of 50% discount. One last information for this, that Gradeup is coming up with the 3rd edition of Gradeup National Scholarship Test on 28th of February for all the engineering streams, civil, mechanical, electrical, electronics and computer science. On the 28th of February, when we celebrate the Science Day. So if you want to win scholarship worth rupees 1 crore, you can go for it. Let us start with the topic. With your due permission, let us start with skin effect. First, we will try to understand the simple definition of what is a skin effect. My friend, skin effect we are defining as it is the tendency of AC current to concentrate near the surface of the conductor, near the surface of the conductor. But this may be in your mind, this question may be coming to your mind, if it is going to be concentrating, the current is concentrating near the surface of the conductor, then why this effect we are calling as a skin effect? The reason is, my friend, that if an ideal conductor is there, if an ideal conductor is present, then AC current can only flow on the surface of the, or better we call it, skin of the conductor, and this is the reason this effect we are calling as skin effect. Varish Kumar, if you think like that, it is better you do not waste your time, okay? Because if you are not coming to the session, then definitely I will not be there to waste your time. My intention here is not to waste your time. So please, you can leave the session and you can utilize your time in whatever way you want. I have not given any personal invitation to you to come to the session. All the candidates who are live in this session with me, they are those students who are regularly coming to my session, and they know that if they are coming to these sessions, they are getting some value addition. If you're not interested, the best thing and the best contribution to ourselves also that you can do is you can leave the session. Thank you so much for your information. Now, my friend, let us try to understand what is the mechanism. What is the mechanism of skin effect? How skin effect is going to come into the picture, that is what we wanted to understand. Suppose we have a conductor like this. Suppose we have a conductor like this. Let me make a bigger conductor. Suppose we have a conductor like this. And suppose you are having an AC current which is passing through this conductor. Because this current is AC current, definitely this AC current. Good evening, Shubha. How are you? Welcome to the session. This AC current will give rise to a time varying flux. This AC current will give rise to a time varying flux, and the direction of flux you can find by using the right hand thumb rule, where thumb is in the direction of current and fingers moving will give you the direction of flux. The direction of this flux is going to be something like this, as per the direction of current, and this flux is going to be time varying. When this time varying flux is going to link with the conductor, eddy currents are going to be generated. Eddy currents are going to be generated. Now, these eddy currents direction is going to be such that they are going to generate a flux which is going to oppose this main flux due to the Lenz's law. These eddy currents will give rise to a flux which is going to oppose the main flux phi t as per the Lenz's law. What is the Lenz's law? Lenz's law says the effect opposes the cause. The effect opposes the cause. Suppose we are saying that eddy currents are generated like this. These are the eddy currents generated in two different parts of the conductor. How we are going to find the direction of these eddy currents? Let us try to understand. If you see this part of the conductor, this main flux is going to be going into the plane of the screen. So the eddy current for this part of the conductor is going to be such that it will give rise to a flux which is going to be coming out of the plane of the screen. So apply the right hand thumb rule. You want the flux direction to be out of the plane of the screen for this part of the conductor. The fingers movement will give you the direction of eddy current. It means the direction of eddy current for this part of the conductor is going to be anti-clockwise. Similarly, Adhika Saxena, welcome to the session. Thank you. So friends, if you see this part of the conductor, the eddy current direction is going to be such that it opposes the main flux. The main flux is coming out of the plane of the screen. So the eddy current direction is going to be such that the flux generated by this flux is going to be into the plane of the screen. If you apply the right hand thumb rule, thumb in the direction of flux because of this eddy current that is into the plane of the screen, and fingers moving will give you the direction of eddy current. So this is going to be clockwise. Everybody just tell me in the comment section, are you able to follow this or not? Now I want all of you to focus on the direction of main current and the direction of these eddy currents. If you closely observe the core of the conductor, the eddy currents are going to oppose the main current. What is the situation? The situation is core of the conductor, eddy currents are going to oppose the main current. Eddy currents are going to oppose the main current. Whereas if you go to near the surface of the conductor, then you will see that eddy currents supports, because they are in the same direction, the main current, and this is the reason that there is a concentration or crowding of the current near the surface of the conductor. So the situation is going to be something like this. If this is your conductor, then the current is going to concentrate only a small portion near the surface of the conductor like this. Now if you want to see the variation of current density, then you can have this type of variation. This is going to be exponential variation. This distance we are calling as 5 del. This distance we are calling as 5 del. What is this del? Del we are defining as the skin depth. What is skin depth? Let us try to understand that. Skin depth, it is the distance from the surface of the conductor, up to which effective current is present. Please try to understand this concept. Effective current is present. This effective current you have to underline. What is this? What is this 5 del distance? Oh my God, Suman Lata, welcome to the session, Suman Lata. What is this 5 del distance, my friend? This 5 del distance we are saying it is the distance. It is the distance over which, or you can say beyond which there is no current. You can underline this. This is how you can differentiate between the skin depth and the 5 del distance, that is distance beyond which there is no current. Distance beyond which there is no current. If you want to write the variation of the current density, that you can write as J is equal to J max e raised to the power minus d upon del. What is this d? D is the distance from the surface of the conductor and this del is nothing but the skin depth. Now this skin depth we can define as the inverse of alpha. What is alpha? Alpha is the attenuation constant. When you talk about the transmission lines in case of electromagnetic field theory or the power system transient analysis, then you read about this constant alpha, which is nothing but the real part of the propagation constant. This is called the change in the magnitude of the wave. Now this skin depth is defined as the inverse of the attenuation constant, and if you see for a conductor the attenuation constant alpha is defined as sigma omega mu by 2. If you are saying del is 1 upon alpha, then you can write del as 2 upon sigma omega mu. You know what is sigma? Sigma is the conductivity of the material, omega is the frequency, and mu is the permeability. Now if you want to define the skin effect, you tell me, if I give you two options, suppose you have two options, this is conductor number A and this is conductor B. Suppose one conductor is having this situation. This is what we are defining as del 1, that is the skin depth for this conductor. Yes, thank you, go Gradeup, good content, thank you beta. Suppose now you are having one conductor where the skin depth is less, so that only a small region the current is going to be present, so this distance we are defining as skin depth del 2. You have to tell me, all of you, please tell me, in which of these conductors you have more skin effect? In which of these conductors you have more skin effect? Can you tell me? Can you tell me yes or no in the comment section? And you can also use lot of emojis in the comment section so that we can make this session more interactive, more funny, more understandable, more absorbing for you. This should not be monotonous and one directional. Now very obviously you can say, if the skin depth is going to be less, the skin effect is going to be more. Aditya Nanda is saying, sir, skin effect by resistivity or cross-sectional area, previous year ESE question. I will come to that. Don't worry. We will discuss that. Don't worry. Now listen carefully. We can write from this that skin effect is inversely proportional to skin depth. So you can say, if you are having a smaller depth, skin depth, then skin effect is going to be more pronounced. Yes, DC Kumar Sena, perfectly correct. Vagmi Saxena, oh my God, thank you beta, thank you coming to the session. So my friend, if you are having a low skin depth, then you can say skin effect is going to be more and more. Now you have defined the skin depth, or you have defined the skin effect as inversely proportional to the skin depth, and skin depth you have defined as inversely proportional to alpha, that is attenuation constant, that you can write as 2 upon sigma omega mu. So if you write it here, it is going to be sigma omega mu by 2. By using this relation, you can understand on what parameters the skin effect is going to be depending. Adityananda, this is the answer to your question. If you see conductivity is more, it means what? If conductivity is more, you are having less skin depth, more skin effect. If you are having more frequency, less skin depth, more skin effect. If you are having a higher permeability of the conductor material, then you are having more skin effect. विद्याश्री थोटा बेटा, ऐसा क्या लिख देते हो जो हटाना पड़ता है? ऐसा लिखते ही क्यों? ऐसा नहीं लिखना चाहिए जिसको वापस लेना पड़े, ऐसा लिखो जिसको वापस ना लेना पड़े. So you can understand, suppose if I ask you a question, suppose there is a copper material and there is a aluminum material to design your conductor. You tell me in which of these conductor materials the skin effect is going to be more. Obviously, you know that the conductivity of copper material is more in comparison to aluminium. That is why you can say if rest of the things are same, the skin effect is going to be more and more in case of copper conductor material. Everybody just tell me in the comment section, are you able to follow this? Similarly, if you are having a higher frequency, because this omega we are defining as 2 pi f. So if the frequency of operation is going to be higher and higher, more and more pronounced skin effect you are going to get. But I want you to understand what is the consequence? What is the consequence of skin effect? That is what I wanted all of you to understand. What is the consequence of skin effect? First of all, you have to understand the basic formula you read for calculation of the resistance for a circularly cylindrical conductor. The formula is resistance we are defining as rho L upon A. But you have to understand the meaning of each and every term you are using in the formula. This rho we are defining as the resistivity of the material. Resistivity of the material, and this is a characteristic of the material. Characteristic of the material. When we say something is a characteristic of something, it means it is not going to be changing. It is a constant. For example, whether you have a 1 meter length of wire or you have a 10 kilometer length of wire, the resistivity, which is the characteristic of the material, it is not going to be changed. What is this L? Please try to understand the way I am trying to make you understand. Otherwise, you will be confused and you will not get the real concept. This L we are defining as the length of the conductor in the direction of current. This is extremely important. In the direction of current. What is this A? Again, my friend, this A is the cross-sectional area through which current is passing. Adityananda, Soumya Nayak. But it is not length of the conductor. Let me tell you, I can give you 10 different situations and you will be confused what is the length. The same concept we use when we talk about the insulation resistance of the underground cable or insulated cables. There we are talking about insulation resistance, where we are talking about leakage current. Leakage current is radially outward. So you have to take that radial distance, not the length of the conductor. That is why I am saying every single term. Now Vindeshwari Thota is saying a very lengthy comment. She or he whatsoever, I am not aware. This candidate is saying, good evening sir, I am studying engineering first year electronics. Could you please suggest me which books can help me to learn the subject more to improve my knowledge? My friend, this is not the right session for you to know the books, because I belong to electrical engineering. How I can tell you all the books for electronics? But definitely if you go to the Gradeup app and the contact number of the Gradeup helpline, if you follow that tomorrow morning, don't do it right now because everybody is busy day out. They are doing so many things, so they may be not available. But tomorrow morning, if you make a call, I am 100% sure that you will be assisted positively. So my friend, this A is the cross-sectional area through which the current is passing. Now let me give you one important comparison. Suppose you have two conductors. One conductor you are passing a DC current, and one conductor you are passing AC current. Now when you talk about DC, the DC current, Prakhar, thank you so much beta, welcome to the session. If you are using a DC, my friend, you tell me a DC current will give rise to a constant flux. When the flux is constant, it is not time dependent and it is linking with the conductor material, it will not give rise to any eddy current. Please try to understand the logic. Eddy currents are only coming into the picture because the flux you are having for the alternating current is time dependent. So definitely when you are dealing with the DC, there will be no eddy currents. So the current is going to be present throughout the cross section of the conductor, or you can say the current distribution in the conductor is going to be uniform, so that the physical area, this we are defining as physical area is going to be same as electrical area. This is electrical area. What is electrical area? Area through which current is passing. But when you come to the AC, alternating current is going to have time dependent flux. So there will be a tendency in the current to concentrate near the surface of the conductor only, and this area we are defining as electrical area. And definitely for this conductor in which you are passing the AC current, you can say the electrical area is less than the physical area. My friend, if you are going to write now the AC resistance, which is given as rho L upon A electrical, and you are saying A electrical is a lesser value than the physical area of the conductor, then definitely the effective AC resistance, this we are calling as effective AC resistance. This effective AC resistance is going to be a higher value. So the consequence of skin effect is that RAC is more than RDC, or you can say with some approximation that RAC is 1.2 to 1.6 times of RDC. Now you are saying because of the skin effect, the resistance is increased. So definitely I square R losses are increased, and when losses are increased, my friend, the efficiency of transmission is going to be reduced. So these are going to be the important consequences of the skin effect. Everybody just tell me in the comment section, और मजा आया तो ताली बजा दो. Are you able to follow me in that? This is the complete picture of skin effect as far as power system is concerned. So everybody just tell me in the comment section, are you able to follow this or not? Extremely important, very frequently asked in various examination. Almost you can say in every 1 or 2 examination, it is going to be having one question from skin effect. Is it clear to everyone? And if you are okay with that, let us move on to the proximity effect. Proximity effect. What is proximity effect? First of all, before I make you understand what is proximity effect, I want all of you to understand what is the meaning of this term proximity. Proximity in English means nearness. Proximity in English means nearness. Now, what is this nearness? Nearness means pass. What is happening with this pass situation? My friend, when you are talking about a skin effect, you are talking about a single conductor. When you are talking about proximity effect, pass की बात कब करोगे? You will talk about nearness or the proximity only when there are at least two or more than two conductors. At least two or more than two conductors. So the situation is, if you are having two nearby conductors and you are having AC currents passing through them, then there is a non-uniform current distribution. What I am saying? What is proximity effect? Two or more conductors near to each other. When AC current is passed, it leads to non-uniform current distribution. Non-uniform current distribution. Now let us try to understand what is the logic. Thank you Kumar Sena, Soumya. Let us try to understand what is the logic. Now when we are talking about proximity effect, we are going to have two conductors. Instead of having one conductor, I will be having two conductors. Suppose these are the two conductors which are nearby. These are the two conductors which are nearby like this. And I want to see if there is AC current in them. If there is AC current in them, suppose this is I1, that is AC current, and suppose I am taking the same direction of current in this conductor also. Suppose this conductor is also having the same current direction. The current is I2, which is also AC. Again, what is happening? Because of this AC current, there will be a time dependent flux, and that flux is going to be something like this. That flux is going to be something like this. For example, if you see this part of the conductor, it is going to be something like this. If this is the current direction, apply the right hand thumb rule. What is the right hand thumb rule? Thumb in the direction of current, fingers moving will give you the direction of flux. Fingers moving will give you the direction of flux. So this time dependent flux is going to be in this direction. Are you able to follow this? Awesome. Thank you Wagni beta. Again, I want to see what is happening with the flux linkages with this part of the conductor. So what I will do, I will have one more flux line like this. Again, the direction is going to be same like this. The direction is going to be same because the current direction is same. So thumb direction in the current and fingers moving in the direction of flux. So this is the situation. But again, this flux phi1t is a time dependent flux because it is due to an AC current. When this time dependent flux, time varying flux is going to link with this second conductor material, again the eddy currents are going to be generated, and the direction of eddy currents is going to be such that they will give rise to a flux which is going to oppose its own cause, that is nothing but this flux. Because of the Lenz's law, effect opposes the cause. So what is going to be the direction of eddy currents? Let us try to understand. For this part of the conductor, the flux is going into the plane of the screen. So the eddy currents has a responsibility because of the Lenz's law to generate a flux which is coming out of the plane of the screen. Apply the right hand thumb rule. Thumb in the direction of flux, fingers moving in the direction of current. So the eddy current direction you will be having as anti-clockwise. Everybody just tell me in the comment section. this much clarity in skin effect and proximity effect that I cannot give you guarantee, but I can assure you that you will not find in any of the power system books throughout if you see. Similarly, if you see the eddy current for this part of the conductor, the flux is going into the plane of the screen. So you want a flux which is coming out of the plane of the screen. So again apply the right hand thumb rule, thumb in the direction of flux that is out of the plane of the screen, and fingers moving will give you the direction of eddy current. So this is also going to be anti-clockwise. DC Kumar Sena is saying once more. See beta, once more what? If you want me to dance, I can dance also. Then you can say once more. But when I am explaining a concept in continuity, if you say once more, I don't know which part I have to repeat. So you have to exactly tell me the problem, exactly where you want me to repeat. You have to tell me the exact point what you want me to repeat. So my friend, what is happening now? I want you to have a close observation of the current, eddy currents, and this main current in the conductor. Eddy currents and the current in this main conductor. Everybody just tell me, are you able to follow this or not? Now you will see that the left side of the conductor, let me just mark it, left side of the conductor, these eddy currents are in opposition with this main current. And the right hand side of this conductor, these eddy currents are in the direction of main current, It means, my friend, we can conclude that if we have two nearby conductors like this, and both the conductors are having current in the same direction, what is happening? The nearest part, the part of the conductor which is nearest to the other conductor, the current is going to be less, and there will be a tendency of the current to concentrate in the farther part of the conductor. So what is happening? The situation is going to be like this. The AC currents are going to be concentrated like this because of the proximity effect. Similarly, if you are having two conductors in which the current is in the opposite direction, then the current distribution will be something like this. Everybody just tell me in the comment section, are you able to follow this or not? Extremely important, and we are discussing it in the most simple way. You want to know the direction of eddy current. Okay, Soumya and Kumar Sen, I will repeat. See what is happening. Let me just explain it again. I am saying these two conductors are having current in the same direction. I want to see the flux because of current in this conductor linking with this conductor. So I am having the right hand thumb rule, thumb in the direction of current, fingers moving in the direction of flux. So I have marked two flux lines, one for the near part of the conductor and one for the farthest part of the conductor. It means the part of this conductor which is near to this conductor and the part of this conductor which is farther away from this conductor. Now if you see, for both of these parts, this flux phi1t is going into the plane of the screen. So what is the responsibility of eddy current as per the Lenz's law? The responsibility of eddy current as per the Lenz's law is that it must generate some flux in opposition to this flux. Both the parts of the conductor, this flux is going into the plane of the screen. So the eddy current direction will be such that they will generate a flux which is coming out of the plane of the screen, Apply the right hand thumb rule. Thumb in the direction of flux, you want flux out of the plane of the screen. fingers moving in the direction of eddy current. So fingers are moving in the direction of eddy current, that is anti-clockwise. That is anti-clockwise. Everybody just tell me. Now I hope you must be getting the idea. Everybody just tell me in the comment section. I cannot give you guarantee, but I can assure you that any book on power system will not give you this much clarity. This is my experience throughout. Everybody just tell me in the comment section. So friends, this is what I wanted to discuss with you. I hope you must have enjoyed the session and you must have got some confidence in the skin effect and proximity effect. But before I conclude, let me tell you what is the consequence. What is the consequence of proximity effect? The consequence of proximity effect is that AC resistance is going to be more than DC resistance. The consequence of AC resistance, the consequence of proximity effect is same as what is the consequence of skin effect. But the idea is different. What is the idea? You are talking about skin effect. You are talking about skin effect. When you talk about skin, you talk about one conductor. And when you talk about proximity, proximity means nearness. Nearness will only come into the picture when you are talking about at least two or more than two conductors. But the effect or the consequence of effect is going to be same. So this is all from my side for today. Let us conclude the session, but before that, let me just give you some important informations. This is about the electrical department, all the faculties from the electrical department who are going to mentor you in the next coming preparation cycle. These are the results we have produced over the years, my friend, and 2020 has been a landmark year when more than 60 students have scored within the 100 all India ranks, and you could be the next one in the frame if you are going to come with Gradeup. My friend, this is the Gradeup Super subscription, just one subscription which gives you access to all the structured live courses and all the online mock tests under the green card. For any further clarification, you can contact this number. Again, I am giving this number here. It is 9650052904. This is the Gradeup helpline number. So this is all from my side, friends. Gradeup Super subscription, which gives you structured live courses, complete doubt resolution, performance and report card, expert faculties, and full syllabus coverage. Let me just brief you the timings of the session so that you can join me in those sessions. Every day on the app, that is Gradeup app, I am having two sessions, one at 1 p.m., one at 4 p.m. This belongs to machines, this belongs to power system. If you want, you can join these sessions. Then Gradeup Gate YouTube channel, I am having one session at 10 p.m. in the night, that is this session, and one session I am having on the Impulse channel. This is also YouTube channel, but this is a dedicated electrical and electronics channel, and this session timing is 6:30 p.m. So these are all the sessions I am taking right now. If you want, you can join them to enjoy the session and learn some of the most important concepts of your core subjects like power system and electrical machines. Thank you so much, friends. Take care of yourself. Prep smart, score better. Go Gradeup. Thank you so much. Thank you. Thank you, everybody. Take care. Thank you, beta.